The next thing we're going to look at with complex numbers is the complex conjugate. What this is a pair of complex numbers that create a real number. So if we are to multiply the complex number by its conjugate, it will create a real number. And there are some instances where we want that to happen. So in order to find the complex conjugate, normally we are in the form a plus bi. The complex conjugate is a minus bi. So keep in mind a plus bi, this does not always have to be a plus sign. We can have a negative here because technically a plus a negative b, we still are in the form a plus bi. And then we would just switch it from negative b to plus b. So we only make the imaginary part negative. So when we are in the form 2 plus 4i, our complex conjugate would be 2 minus 4i. If we started with 2 minus 4i, we would put 2 plus 4i. So we're taking the sign, whatever it is, in front of the imaginary number, and we're making it the opposite. So one thing we'll need that for is when we are dividing complex numbers, because this form right here is not a standard form of a imaginary number. A standard form is in the form a plus b I. I can't just take this fraction and split it down the middle and say 2 over 4 plus minus 3i over 2i. That's not how fractions work. We can't split it up like that. So in order to write out the quotient of this, so divide these two complex numbers and write them in the form a plus bi, we need to use the complex conjugate to make our denominator a real number. So 4 minus 2i, the complex conjugate of that is 4 plus 2i. So if I use 4 plus 2i, just gonna make this look a little bit neater, and multiply my denominator by that, I will get a real number in the denominator, which is what I want. But to keep this fraction equal, I can't just do that to the bottom. I also have to do it to the top as well. Because now technically, if we multiply something by that thing over itself, we're multiplying by 1. So I'm not changing my fraction, I'm just rewriting it. So over here, I'm going to FOIL out the top and the bottom. So 4 times 2 gives me 8. And then 2 times 2i plus 4i. And then here we do 3i times 4, we get plus 12i. And then 3i times 2i plus 6i squared. So don't forget, if you're multiplying I times I, you get I squared. So now to simplify this, we can combine like terms. I squared becomes negative 1. So we get 8 plus 16i minus 6, because 6 times negative 1 gives me negative 6. To simplify it even further, 8 minus 6, so we're combining these like terms, 2 plus 16i. So after all that work, we have finally simplified the numerator. Now let's work on the denominator, and keep in mind we should get a real number. So 4 times 4 is 16. So all of this is on the top. I'm just going to put a huge fraction bar. And then we have 4 times 2i plus 8i. And then negative 2i times 4, negative 8i. And then negative 2i times positive 2i minus 4i squared. So once again, combine the like terms. I squared becomes negative 1. So positive 8i minus negative 8i cancels out. So we're left with 16 plus 4 in the denominator, because negative 4 times negative 1 gives us positive 4, which equals 20. So now, taking a look at this final fraction here, I am going to rewrite this. This is my final answer, 2 plus 16i over 20. Now that we have one number in the denominator, we can split this up as 2 over 20 plus 16 over 20i. As you can see, this is now in the form a plus bi, my real number plus my imaginary number. Now, the last thing we want to do, if we can simplify the fractions, we do want to do that. So we get 1 over 10. We divide both of these by 2. So we get 1 over 10. And we can divide both of these top and bottom by 4. So we get 4 over 5i. And that is our final answer.